Wow, I actually did it. I'm in math. This is awesome. It's okay, nothing can hurt me here. Wait a second. Hi everybody, I'm your host, Mr. Wheeler, and welcome to another edition of Lost in Math. Today we're talking about experimental probability. So to do experimental probability, we have to run experiments. In math, an experiment is any activity involving chance. So think like rolling a dice or drawing a card. Each time we run an experiment, it's called a trial, and each result from an experiment is called an outcome. And the set of all possible outcomes is called the sample space vocab. First thing we're going to do is talk about sample spaces and try to identify them. So if we look at our first two examples on our notes, could you identify the sample spaces in those problems? The first example asks us to identify the sample space from rolling a number cube or a die. On this one, there's 6 possible outcomes because the cube has 6 sides. We could get a 1, 2, 3, 4, 5, or 6. On example 2, it asks for the sample space involved in flipping 2 coins. First, we look at our first coin. There's 2 possible outcomes. It could land heads or tails. Then for our second coin, it also has 2 possible outcomes, heads or tails, but we have to look at it all together. So I got 4 possible outcomes from that. I could have got a heads, then a tails, or a heads and then another heads, or a tails, then another tails, or a tails, then another heads. So those are the 4 outcomes in our sample space. An event is an outcome or a set of outcomes in an experiment. Probability, the thing we're going to be talking about for most of today, is the likelihood that an event will occur. Probabilities can be written in a number of ways. They can be written as decimals between 0 and 1, or as fractions, or as what's most often done, percentages. So like there's a 20% chance it's going to rain tomorrow. That's a probability. So probability is a likelihood an event will occur. If we look at this little bar, we have some vocab to help us apply words to the likelihood of an event. There's 0% chance it'll occur. It's impossible. It cannot occur. If there's 100% chance, it's certain. It will definitely occur. And then we got everything in between. Right at 50%, it's as likely as not. In between 50 and 100, we say it's likely to occur. And in between 0 and 50, we say it's unlikely to occur. So if we look at those examples, which one of those terms would best describe each situation? Impossible, unlikely, as likely as not, likely, or certain? Take a moment to try that. So example A, there are 31 days in August. After consulting my calendar, there are 31 days in August, so that's certain. There will always be 31 days in August, so that's 100% probability, so we write certain on example A. Example B, Niles correctly guesses a number between 1 and 1,000. I don't know Niles, but that's unlikely. It's not impossible. He could get it right, but he's probably going to get it wrong, so there's less than a 50% chance for sure that he's going to get it wrong, so we write unlikely on example B. Example C, a coin lands heads up. That is as likely as not. There's 2 options, heads or tails, so there's an equal chance of both. So it's as likely to happen as it is not to happen. Celia rolls a 10 on a standard die. A standard die has 6 sides. Die means one dice. So the highest number she could get is a 6. So that's impossible to roll a 10 on a standard die. So we write impossible on example D. Like I said, today we're talking about experimental probability. In order to find experimental probability, you actually have to run an experiment. On your notes right here, it asks you to randomly draw cards and keep track of whether they're spades, hearts, clubs, or diamonds. If you have a deck of cards at home, feel free to do that. The more times you run it, the more exact it'll get. If you draw all the cards, it'll get a little too exact, so just draw like 20 or something and record all your findings. I'm going to be finding the probability of rolling different numbers on this 12-sided number ball a student did a horrible job trying to make. It's not going to be fair because there's a bunch of mishmashed sides. So I'm going to keep rolling this and see what happens.
One eternity later.
398. 399. And 400. So to find experimental probability, you want to find the number of times an event occurred, so whatever it is you're looking for, how many times that happened, over the total number of trials, the total number of times you ran your experiment. So for example, if you did the drawing cards thing and you were trying to find the probability of drawing a diamond, you'd say how many times you drew a diamond. So let's say it was 5 times out of the total number of trials. So let's say you drew 20 cards total. Then your experimental probability would be 5 over 20, or 1/4, or 25%. For my experiment, I wrote down all of my findings in this nice little table, and I'm going to find the experimental probability of rolling an 8. So experimental probability of rolling an 8, I rolled an 8 28 times, so that's how many times it occurred. And I did a total of 400 trials, 400 different dice rolls. So my probability experimental would be 28 over 400. If I converted that to a percent, that's 7%. So the experimental probability for me of rolling an 8 was a 7% chance. We can also find the probability of something not happening. So for instance, if I wanted to find the probability of not rolling an 11, we'd find out how many times I didn't roll an 11. That would be what's on top. That's how many times the event of not rolling an 11 occurred. I only rolled an 11 twice. That's because on the other side of 11 was this 2. There it is. Which is pretty messed up. And it was very difficult to land on the 2, which would have got me my 11. So since I only rolled 2 11s, that means I did not roll 398 11s. So on the top of my fraction, I'd have 398, because that's how many times that event occurred over my 400 total trials. I could change that into a percent. That'd be 99.5. So there's a 99.5% chance of not rolling an 11. On your example B, it asks for the number of times a spade is not drawn. So if a spade is not drawn, that means I either drew a club or a heart or a diamond. So you'd add all those together and then put that over your number of total trials, and that would be the probability of not rolling a spade. So hopefully you can do that okay. I can't really help you because I'm trapped in math and everything, but you got it. We can use experimental probability to help us make a prediction. A prediction is a guess about something that hasn't yet happened. So on our example here, it's about quality control. A manufacturer inspects 800 toy dolls and finds that only 4 of them come to life and go on a murderous rampage. What? So question A, find the experimental probability that a doll will not go on a murderous rampage. So take a moment, think about how you might do that. So we're looking for the probability that a doll will not come to life and go on a murderous rampage. 4 of those happened. So that means out of the 800 total trials, 796 times it didn't happen. That's a plus. So that's our numerator. That's how many times it occurred. 796 dolls that were perfectly fine over our 800 total trials. So 796 over 800. We can convert that into a percent. And that's our answer of 99.5% again. So there's a 99.5%. And if you buy this doll, you'll probably be fine. On example B, the manufacturer shipped 5,000 dolls to a retail store, and we want to predict the number of those dolls. That'll be perfectly fine. We can use our answer from example A to help us in this problem. I know that the experimental probability is 99.5% that a doll will be fine. So if there's 5,000 total dolls, I know that 99.5% of those should be fine. There are a lot of ways to find percent of a number. I'm going to change my percent into a decimal and multiply. So 99.5%, that's 0.995 times 5,000. And I get my answer of 4,975. So that means out of the 5,000 dolls, 4,975 of them will be perfectly fine. That's it for our notes on experimental probability. Thanks for coming down. And if you can find a way to get me out of here, I'd appreciate it. Bye, guys. So for experimental to experimental probability, we have to, I was too far from the mic. So for experimental probability, experiments in math or in probability involves chance. When we run these, each time we run man, it's hard. Event will occur. If we look at our examples down here on our problem, on our paper, in our paper. So if we look at those examples, which one of those terms we just went over would most miles, but it's not likely, unlikely. Less than a 50% chance for sure that he's going to get it wrong. So we write unlikely on example B. Ugh, tasted that one. Example C, a coin land heads. Now today we're talking about experimental probability. So I got lots of things to say about that, I'm sure. So experimental probability rolling an 8. I rolled an 8, 8. So we're looking for the probability that a doll will not come to life and go on a murderous rampage. Wait, no we don't. Yes, that's right. In order to find percent of a number, there are a lot of ways to find percentages. Lots of ways to do it. I'm going to turn my percent into a decimal and then